This animal can detect you before it sees you. It can sense your heartbeat and decide you are not worth its attention. It has spent 60 million years in this ocean. It can cross it entirely in weeks. And when it disappears from an ecosystem, that ecosystem starts to change from the top down. This is the great white shark, and it is far more than a predator. Inside a shark cage in Mossel Bay, you understand something quickly beneath the water. The human being stops being the observer. You are inside a cage. It is not. The ocean covers 71% of the Earth's surface, and yet we know it is less well than we know the moon. It is the largest, deepest, and darkest ecosystem on planet Earth. And for 400 million years, the sharks have been its invisible guardians. Not guardians in the poetic sense, guardians in the precise ecological sense. Animals that by their position in the food chain control the behavior of everything below them. Without predators at the top, ecosystems don't just work worse. They work differently, in a way that tends towards chaos. The great white shark is the largest active predator of marine mammals on the planet. The last great white shark that regularly hunts seals and sea lions. Its ancestors have been in the ocean for over 6 million years. They survived the extinction that erased the dinosaurs. They survived the Earth's changing entirety. Off the coast of South Africa in the cold waters of Mossel Bay and False Bay, this species was for decades one of the most studied on the planet, until something changed, until it began to disappear. And then the ocean showed us what the great white shark actually does when it is there. Largest active predatory shark in the world, females can reach up to 6 meters and weight close to 2 tons. Males are smaller, between 3 and 4 meters. They are not the biggest shark in the ocean. The whale shark is 3 times their size, but the whale shark eats plankton. The great white hunts seals, and that changes everything. It has up to 300 teeth, and it never truly loses them. Its teeth are arranged in rows, like a conveyor belt. When one falls out, the next takes its place within weeks. Over the course of its life, a great white can produce more than 30,000 teeth. Its mouth is always ready. Its bite is one of the most powerful in the animal kingdom. Over 18,000 newtons of force. But what makes the great white lethal is not just that force. It is the strategy bite release weight when it shakes its head while biting. Its serrated teeth tear tissue in a way that no direct pressure could replicate. It is a tool designed for efficiency, not spectacle. Its liver is its biggest secret. It can represent nearly 30% of the animal's total weight, up to 300 kilograms of fat. That fat does 2 things. It keeps the shark buoyant without constant swimming, and it stores energy for crossing entire oceans. It is the organ orcas specifically target when they attack a great white, and that tells us everything about how valuable it is. It can keep itself warm in freezing water. Most fish have the same body temperature as the water around them. The great white does not. It has a system of blood vessels that work like a heat exchanger. Warm blood leaving the muscles preheat cold blood coming in. Its muscles can be up to 14 degrees warmer than the surrounding water. The result? It moves faster, reacts sooner, and can hunt in cold waters where other predators of its size simply cannot function. Look at the great white's skin up close, and it is not smooth. It is covered in tiny scales within a specific shape that guide water around the body, reducing drag. The manufacturers of Olympic swimmers copied this principle in the 2000s. The shark has been using it for millions of years. It goes slowly almost all the time and very fast when it matters. Its normal cruising speed is 3 to 4 kilometers per hour. That is how it conserves energy for hours when it attacks. It can reach over 40 kilometers per hour in seconds. Its entire survival strategy is built around that 1 moment minimum expenditure of maximum result. The great white's sense of smell is extraordinary. It detects blood at a concentration of 1 part per million. 2/3 of its brain is dedicated to processing olfactory information, and when it tracks a scent, it does not swim straight towards it. It moves in a zigzag, triangulating the direction like following an invisible map. It has a sense humans do not have. It detects electricity. The pores you can see on a great white snout are not decorative. They are organs called the ampullae of Lorenzini. They detect the electrical fields produced by any living creature. When it moves or breathes, every animal with active muscles generate electricity. The great white can feel it at several meters distance, even in the total darkness, when it bites and rolls its side back to protect it. Those organs guide the final strike during that instant of blindness. It feels water movement before it sees anything. Running along its body is a sensory tunnel called the lateral line. It is filled with cells that detect vibrations and pressure changes in the water. If something moves nearby, a wounded fish, a person thrashing, the shark perceives it or seeing it before smelling it. It is like having ears across your entire body. Attacks on surfers are usually cases of mistaken identity. When the shark looks upward from a backlight, it cannot easily tell apart the silhouette of a surfboard with a human on top from a swimming seal. Visual studies confirm the silhouettes are remarkably similar from the angle. That is why most incidents with humans are brief. The shark bites, realizes the mistake, and leaves. The problem is not the intention, it is the size of the animal. It can live for more than 70 years. For a long time, scientists believe the great white shark lived around 25 to 30 years. Then they learned to read its vertebrae like free rings, and they found out individuals that were over 70 years old. It is one of the most long-lived vertebrates in the ocean, but it takes decades to be able to reproduce. Males reach sexual maturity around 15 years old, females up to 33, and when they do reproduce, they have between 2 and 10 pups. That means if a female dies young, from a fishing net, from a boat, from any cause, the ocean loses decades of potential reproduction. This is an animal that cannot afford to lose individuals. How it hunts. The perfect ambush. In places like Seal Island in South Africa, the great white patrols silently at 10 to 30 meters depth. Its dark dorsal side blends into the seafloor. From down there, it looks upwards and waits to see the silhouette of a seal against the illuminated surface. When it spots one, it accelerates vertically in seconds. It goes from still to over 40 kilometers per hour sometimes, and the momentum is so great that the animal exits the water completely. That is called breaching. It is one of the most spectacular sights in the ocean, and it is pure predatory mechanics. It bites, releases, and waits. It does not fight. When it attacks large prey, an adult seal, a sea lion, the great white, does not try to hold it. That would be dangerous. Large prey fight back, scratch, thrash. Instead, the shark makes a single deep dive that cuts with arteries and then moves away. It waits the prey to bleed out. The shark returns when there is no longer any risk. It is the most efficient strategy possible. Maximum damage, minimum risk. What looks like an attack on humans almost never is. The great white does not have hands. It uses its mouth to explore the world. When it bites a human and releases, in the vast majority of cases, it was investigating. Humans are not its preferred prey. We do not have enough fat. The problem is that a single exploratory bite from a 600-kilogram animal can be fatal. Not aggression, curiosity from an animal that does not calibrate its own strength well. It is smarter than it looks. Researchers working with great whites in South Africa have seen surprising things. Individuals that learn which boats bring food. Animals that react differently to a familiar researcher versus a new one. Behaviors that have no simple explanation. The great white is not a machine of instinct. It observes, evaluates, and adjusts. It has memory, and it has preferences. When it disappears, the ocean changes. Between 2015 and 2018, great white sharks practically vanished from Mossel Bay in South Africa. What happened next was documented by researchers at the University of Miami and published in the scientific journal Frontiers in Marine Science in 2025. What they found was a perfect example of what ecologists call a trophic cascade. Seal sightings multiplied by 5. Without the great white controlling the seal population, seal sightings increased by 522%. That sounds like good news. It is not. More seals mean more pressure on the fish they eat, and that began to affect the species down the food chain. One piece removed, the whole system starts to shift. Other predators took its place, but not in the same way. Without the great white, seven-gilled sharks, a smaller predator that normally lived within kelp forests, started appearing in open water, and they started eating things they had not eaten before. The balance that had taken millions of years to form reorganized itself in months. The fear also disappeared, and that matters. Mossel Bay seals had elevated cortisol levels, the stress hormones, when great whites were present. That it's not suffering, it is alertness. That alertness kept them distributed, on the move, not concentrating too heavily in any one place. When the shark disappeared, the cortisol dropped. The seals relaxed and started pressing more intensely on the coastal fishing resources. The predator does not only hunt, it organizes. Ecologists call it the ecology of fear. The simple presence of an apex predator changes the behavior of everything below it in the food chain. Even when it is not hunting, seals avoid certain zones. Fish change their routes. Resources do not pile up in one spot. When the predator disappears, that order disappears too. The ocean does not just lose a hunter, it loses its organizer. Two orcas changed the ocean of South Africa. In 2017, two orcas with deformed dorsal fins began appearing in the water of Bay and Mossel Bay. They became known by their names, Port and Starboard, and they started doing something no one had documented before: hunting great white sharks systematically. In 2022, one of them killed a great white in under 2 minutes. Alone, the carcasses that washed ashore had one thing in common: the liver was gone, removed with a precision that suggested practice, not instinct. The great white sharks left. They did not all die, they moved. Satellite tracking data showed the sharks redistributing eastward: Mossel Bay, Lorenzini Bay, Algoa Bay, but then the orcas followed. The question researchers still cannot answer is whether the shark will return, or whether a population that reproduces this slowly can recover from that kind of pressure. The orcas are not the only problem. Great whites were already disappearing from Mossel Bay before Port and Starboard arrived. Beach protection nets, accidental longline fishing, habitat alterations, all of that was already in place. Researcher Alison Towner from Rhodes University described it like, the orcas are petrol on a fire that already existed. The fragility of the great white started long before. When a great white shark approaches the cage, it does not do what films show. It does not ram the metal. It does not open its jaws in rage. It swims slowly, with the calm of animals that have nothing to fear. And when it looks at you, you understand that its presence here is not random. It is the result of 60 million years, and when it is gone, the ocean notices. The great white shark does not need our admiration. What ecology asks of us is that we understand what it is for, not its image, its function. For decades, we treated it as a problem to be solved. Beach nets, indiscriminate longline fishing, sport hunting, all built on the same mistaken premise that ocean would be better with fewer great whites in it. Seal Island show us the opposite. When it disappeared from Mossel Bay, the seals multiplied by 5. Other predators moved into zones they had never occupied. Coastal fish started to disappear. An ecosystem that took millions of years to calibrate reorganized itself in months. An ecosystem that took millions of years to calibrate reorganized itself in months. Removing an apex predator never affects just one species. It affects the entire system, because great white predators do not only hunt, they distribute risk. They keep their prey moving. They stop resources from piling up in one piece. When they disappear, that order disappears too. Inside the shark cage in Mossel Bay, you understand something that cannot be explained while on land. It is not exactly fear, it is perspective. The perspective of being a land mammal facing an animal that has inhabited the same ocean since before the Mediterranean existed. There are fewer than 3,500 great white sharks in the world. An animal that takes decades to mature, that cannot recover quickly, has no replacement. The ocean never stopped belonging to it. The question science now puts to us is not whether we are afraid of it. It is whether we understand what we lose when it disappears.